I'm Ian.
I'm Mariana.
I'm Olivia.
I'm Cordelia.
And this is
Trevor. It's Trevor.
Trevor is our project. He is a robot, as you can see. He has an optical sensor. He can detect color. He can also detect not just color, but if an object is in front of him, and he knows to turn away from that object.
He also has a special ability of being able to flip upside down and continue to drive upside down. So first of all, we can use this purple block as an example of an object. So when he senses that object, he will pick up the object, and after taking a pause, he'll begin to drive again, although we don't want him to drive off the table. So the rest of the demonstration will be on the floor, where if we use the door as an example of a wall or an object that we don't want him to grab, he can move ahead, and once he senses something, he'll stop and turn and keep moving randomly.
Yay!
He might get a little stuck in this situation though. And he continues to do so on and so forth forever and ever. And also, he has, of course, as said before, the ability to, if he gets flipped upside down, if he is flipped upside down, he will also continue to be to keep running. Long code.
And you get
He's not going to be able to turn very well around.
You're stuck.
Well,
Could be.
Could you demonstrate the driving action?
Yeah.
sorry.
Should we redo it?
Drive it towards the camera, maybe. Let's see if you can back up behind Asha's foot. So Asha remains standing.
Okay.
Move
a bit. Move in front of it.
Senses use an object. He has a lot of struggle turning on the carpet, so the table is better really for this demonstration. But he'll start back and keep running. Shaheen! Gonna get him stuck. We want him to sense something. But yeah.
So the grabbing demo, can you do it on the floor? Can you grab on the floor?
He'll sense an object, and he will come pick it up. And after a while, takes a second, but he'll keep moving along with that object. Oh, okay.
Yeah.
And that is Trevor.
All right.
So this is our presentation on Trevor and how we made it.
Defining the problem. So essentially, we created. But that's reading off the slide. Okay. May it be NASA, the military, or any other corporation, big corporation, keep that in mind. There are always struggles. Maybe from moving something to fighting everything in between, Trevor can cover it. If one man goes down, Trevor can come and assist. Can't transport something, leave it to Trevor to carry out the task. We want to battle, but we want a battle bot, but don't have one. Trevor is.
Yep, he's a green one.
Okay, our decision matrix. So after all gone through what we think the client would want, we started to kind of put it all together and look at all of our ideas on the board. And so as we went through this all, we looked through each of our decision matrix, trying to come in with an unbiased mind so that we could get the best product out of Trevor we could.
To mapping it out, basically. So we decided to sketch it after, and then we did the flowchart. And so during we were making these, we would also more or removing stuff from how much when we were building it how much he changed along the way. In the end, we decided to kind of like merge all our ideas from the decision matrix together to form what we know as today. Trevor.
Making the adequate changes needed. We went through a couple pitches about what we continued to grow as we continued to assemble.
So this is what we used to make him. So after we got a solid idea of what we wanted, we started to grab our materials and what we needed. And so over to my right, there's a list of all.
Too many. But
So those
all
are
of
all
those.
the materials that we used to create Trevor.
Also, a lot of zip ties and twist ties.
Once we assembled, when multitude of changes we had made was endless. From loose screws to the let's get closer to the end, our termination was sealed. As stated, one of the most complicated parts of our testing was the code constructed. Our optical task would go back.
Say one more thing before we move on. Trevor went through a lot of like design changes beforehand. For example, we had unnecessary Roomba hooked parts in the front that were not necessary to the overall function of the robot and also affected his ability to move upside down. So we had to change that in order to allow him to do his best job, his best intelligence big brain moment.
So Trevor took a very long time. It was a rough process. Hitting all the points took work and dedication that was just so much. It paid off really well though. We were all super excited about making. He's able to drive upside down. He can, if you trigger the certain buttons, he can grab things. He can do all these things that we never would have imagined when we just started. So we're able to accomplish all our goals and more.
Surplus of time we were given, we let out great These are just videos.
These are
We've already
videos.
showed you all.
Okay.
He detected it as an object though back then. That was some of the code issues that we were talking about.
It's also just the optical sensor in general because it would reflect off the red light.
So
It should be.
Simon was helping us.
Yeah.
Oh, that's Simon.
Yeah.
Simon.
Honorary guest, I could say.
Honorary guest. Done you all these, but
Oh, and here.
it's upside down.
Much better than. That is the end.
All right, let's give a round of applause.